On Friday, we talked about how to take the derivatives of inverse trig functions. Question, do you have a snazzy formula for inverse functions in general, especially those that you can't switch x and y and solve for y for? Yes, but are we going to use that with trig inverse? No. Someone nudge Aaron and say, hey, good morning. No. So, it's a rough morning. Instead of using that, which would be kind of a nightmare, it wouldn't be impossible, but it would be kind of hard. We have these formulas that we can memorize and make life easy. However, let's remind ourselves where these formulas come from. So let's do one more quick proof. I'm not going to prove all 6, even though I could. I'm just going to prove one more in order to show us, too much light, in order to show us, that's better, where these formulas came from and to further show to you guys that they are what they are, which is kind of weird because you start with a trig, that's a trig inverse, and the derivative has no trig in it at all. No trig in it at all. Which is kind of weird and yet still possible. Let's pretend we didn't have the formulas. If we didn't have the formulas, how would we start this problem? By getting rid of the inverse and saying, ruh-roh, we don't know how to deal with them. So if we didn't have those formulas, we would get rid of the tangent inverse by taking tangent of both sides. And then we would say, hey, let's take the derivative of him. So we're going to do ddx of one side, ddx of the other, with implicit differentiation because we can, of tangent of y and 2x. All right. Come on, amazing ones. How would you take the derivative of tangent of y? Secant squared of y times, why is there a times? Because there's a y in there, so I need y prime times dy dx equals, and on the other side, the derivative of 2x is? 2. Now, if you notice, this also has a chain rule. I wonder if that's going to work out. Charlie, you're chilling, never mind. Come back. Is there any nicer way of writing 2 over secant squared of y?
Sure.
Wait, amazing ones, come on, this is recal. Is there any easier way of writing 2 over secant squared? Over secant squared. Charlie! Over secant squared. Secant squared is who? Who thinks about secant?
1 over cosine.
Secant is 1 over cosine. If I already have an over of secant, then question, what could I change this to be? 2 cosine squared. Now, isn't that easier? Remember, if secant is the reciprocal of cosine, then cosine is the reciprocal of secant. And the squared, I could pull that all the way out, and then I could change it to cosine and then bring the squared back in either way. Now, this is not the derivative formula that was on the page before because it still has a trig in there. Why? Because if we go back to the very beginning, remember, tangent of y is the angle, 2x is the ratio. And if it's tangent, question, what is it the ratio of? Or I should say, what ratio does it represent?
Opposite.
Opposite over adjacent. But wait a minute, there is no over. Wait. Who could I make 2x over? Oh. So I can come over to my little triangle and say, oh, that's right. Y is the angle, 2x is the opposite, 1 is the adjacent. How could I solve for the third side of moving ones?
2x squared plus 1.
Pythagorean theorem, 2x squared plus 1. 2x times 2x is 4x squared plus 1. Now, how do I find cosine? What? Why am I finding cosine? What am I having you do? Go look at the triangle and say, wait a minute, we know who cosine is. So who is cosine? Adjacent over hypotenuse. Plug and chug. So if the derivative is 2 times cosine squared of y, which is the same thing as 2 times cosine of y, which is needs to be squared, I could say 2 times 1 over 4x squared plus 1 squared. Remember, don't get tricked by the trig notation. Cosine squared of y is the same thing as the cosine being squared. What happens when you square a square root?
Bye-bye.
So you end up with 2 over 1. 4x squared plus 1. Now, let's take this derivative another way. Using those snazzy formulas that we wrote down. Don't worry, I'll dual page it, just in case anyone wants to get what's up here. Look at forever card number 17. What is the derivative formula, d dx, of tangent inverse of u? 1 over 1 plus u squared times u prime. Question. Who in this example, when we're trying to find the derivative of y equals tangent inverse of 2x, who is u? 2x, right? So if I just go plug in and chug it into my formula, then I could say dy dx, remember, because y is alone. The derivative of y is dy dx, go to the other side. The derivative of tangent inverse of u is 1 over 1 plus u squared times, who's u prime? 2. So I end up with dy dx equals 1 over 1 plus 4x squared. Wait, can't I make this a 2 over 1 and bring them in?
Yes.
2 goes up top. 2 times 1 is 2. Which way do you like better? Formula, but in order to use the formula, what do you have to know? The formula. You have to memorize it and keep it forever. So, formula works. Technically it all comes back to a triangle though, which is kind of interesting. So when you're looking at all these formulas, you're like, ugh, they're ugly and they're disgusting and they're nasty and they're all different variations of Pythagorean theorem. Right? Because you have square root over here of hypotenuse squared minus side squared. This one you have opposites squared plus adjacent squared, or a squared plus b squared. This one down here, well, Seekin's a little bit rough. And I could prove him, but you guys are probably done proving, and you're like, wait, I like the formulas, can we just use them? I'll be like, okay. But this one is kind of, hold on. The variable is the hypotenuse. It's hypotenuse squared minus, which one do we do, opposite? Or adjacent? So I think adjacent squared. But then we have an extra little piece which would work out with the proof if we did it just the same as the other two. Okay. With that, let's just practice some more with formulas. So you guys need to have that Forever 17 really close, okay? Otherwise you're going to be totally lost as to what we're doing and why we're doing it. However, if we can just use formulas, only for trig inverse, yeah? If we can just use formulas, then you tell me what formula am I going to use for sine inverse of 1 over x? 1 over 1 minus, who's my u? Times u prime. Now, if you don't like the 1 over x question, can't you rewrite him to be sine inverse of, what's another way of writing 1 over x? X to the negative 1. Now, just a few of you are rewriting it before simplifying in the derivative in the sense of you would write this as a negative 1. Your brain doesn't compute, most of you. If you were to write x as a negative 1 right here, your brain is like, oh, what on earth am I supposed to do with that? We can work better with fractions when we're doing it. We rewrite it in order to make taking the derivative easier, like when I go to do u prime, how do I take a derivative of x to the negative 1? Yeah, negative x to the negative 2, which is the same thing as, have we gotten to where we can jump now? Who is he? Negative 1 over x squared. Okay? Do what you need to do. But your brain, believe it or not, works much better in fractions than it does with negative exponents. Now, here's a struggle, and you're gonna hate me just a little bit, but it's okay, because I'm getting you ready for stuff. You can't box that and be done. Just because this would not be a long answer, free response question on the AP, it's gonna be a multiple choice, if it's there at all. There's always at least one inverse trend. It's gonna be a multiple choice, and you're gonna have to simplify. So someone tell me something, huh? You're sweet and smart. A little smart. Question. You have to make it match, and believe me, the answer looks way different than this. Tell me something, what can we do? Charlie?
Question.
Oh.
The AP, how do you feel about us if we get there and we just plug in one and see which one matches?
It's not necessarily a bad idea, but
It's like,
what if the correct answer is E and you do it to like 4, I don't know, depending on how complicated, you might do some bad math and end up choosing the wrong one.
okay.
But it's not a bad strategy if you're totally stuck and you're like strapped for time and you're like, whatever, I don't wanna simplify, or you're like, I always simplify wrong. Okay? And you can test it on tests now, but it's up to you. It's up to you. You do have free will. You do have free will. All right, coming back. How do we simplify? Can't really multiply by a square root. I mean, we could try to do a conjugate-y sort of thing. But the conjugate of this is going to make everything kind of worse. So maybe not the conjugate. Do what's the square root? But that's killing a puppy, remember? We could do like 1 plus 1 over x times 1 minus 1 over x, but they're not a perfect square, it's a difference of squares, that's not gonna help. Common denominator. What? But I don't have any addition or subtraction. Look, if we were to do 1 over, can I put the little x squared in front, because he's just chilling, right? And I can make that a negative. 1 times negative 1, that's a negative 1 up top, x squared just comes in front of the square root. We have 1 minus, what did Brandon mean by a common denominator? I need to put this as together as possible. What do I mean by as together as possible? How can I rewrite, or how can I change the 1 to have a denominator of x squared? Put them in. This is one case where my nifty little trick does not necessarily work yet for simplifying a complex fraction. Then I can say this is the same thing as negative 1 over x squared square root of x squared minus 1 over x squared. It's one big square root. Why was that allowed? Because I got a common denominator, so I could put these fractions together. Remember, just a few of you make this simple algebraic mistake, or the common algebraic mistake. When you combine fractions with common denominators, you change it, but you don't. The denominator stays the same. Remember, 1/3 plus 1/3 is 2/3. X squared over x squared minus 1 over x squared is x squared minus 1 over x squared. That stays the same. Now, Lauren, this is legal. As long as you don't distribute the square root, it's legal to split up because I can take square root of the top and square root of the bottom. That's not illegal in terms of like pretending something factors when it doesn't. So now I will split up that square root. To be x squared times the square root of x squared minus 1 all over the square root of x squared. Some of you may dislike the next step, but technically it's true. That'll give you negative 1 over x squared square root of x squared minus 1 all over absolute value of x. I know I told you you wouldn't like it, but the square root of x squared is absolute value of x. I have to maintain that it's always going to be positive, even after taking away the square root. And last but not least, move that puppy. Move that puppy. There's my little trick. Let's get rid of him. Move him to the top. We end up with negative absolute value of x all over yeah, it's gross. It doesn't look a lot different than what I did a second ago. if you have to make it match, we need to see what would be waiting for us in multiple choice answers. Now let me quickly look at this and make sure that we still need that absolute value. Sometimes positive, sometimes negative. This one will actually always be negative, and if I took away the absolute value, if I put in a negative number, it would sometimes be positive. Yep, I have to keep that absolute value. All right. Nasty. Nasty, nasty, but we have an example of the nasty. What made it hard? U was a what? Yeah, U was a fraction. Which means when you plugged it into a denominator, then you had this little complex fraction-y thing under a square root. We had to simplify, get common denominators, et cetera, et cetera. Some of you might have been able to skip a few of those steps, but please, if you're skipping steps, make sure that you are staying spot on the whole time. Now, what if I gave you this one? Woo! No fraction in the U. All right, less is better. Simplifying is not going to be as rough. You guys tell me though, what's the big picture? What's the rule that we need to track? Well, there is an inverse, but that's not the big picture. No. What's the big picture?
Product rule.
Product rule, right? Are we all tracking? Yeah. Okay, so product rule, I need a first. And I need a first and I need a second. Okay. How does product rule work? Hold on, dy dx, right? Don't need to worry about implicit, y is by itself. Okay, second d first. Ah, nice, just rewrite it. Sine inverse of 3x times, what's the derivative of e to the x? My favorite, e to the x. Plus, first, e to the x times, okay, formula. Formula. Texting in class, would be ashamed. Mrs. Regan would be so ashamed. Derivative is 1 over square root of 1 minus u squared times u prime, which is 3. And you guys know in multiple choice there's going to be an answer that does not have the times 3. And so we have to be super careful. I'm going to rewrite it just to make it a little bit nicer, writing that little e to the x in front. Remember? 3 and e to the x, they all belong up top, right? For the fraction. And then down below, square root of 1 minus 9x squared, true? Don't kill a puppy, you can't take that square root. It'd be 1 plus 3x times 1 minus 3x. That's not a perfect square. Is there anything I can do? Maybe common denominators, but doesn't make anything nicer. The only thing I can see they would do, does anybody see the one thing I might?
Pull it into the x.
Yeah. Why am I only pulling a 3 to the x out? Or no. Why am I only pulling an e to the x out and I'm not pulling out a 3?
Because the 3 is trapped in the sign.
1 3 is fair game, but the other one is trapped in the sign and he cannot come out. Remember? Just a few of you might try to pull out that 3 and that might be one of those common mistake multiple choice things. The 3 can't come, but the e to the x can. Dun, dun, dun. Did that work? I know. You guys, you're so pitiful. In a somewhat cute way, but still. Pitiful nonetheless. Alright, did we get it? Sorta, kinda, maybe? Maybe, sorta, kinda? Okay, next one. Ooh, it's a tangenty one. It's okay. We have a formula for a tangenty one. So, return the function f of x equals tangent inverse of u. Oh, sorry. Tangent inverse of 2x plus 1. Perhaps it was a Freudian slip. Because 2x plus 1 is who? Not me. I'm tough now. So, the rest are still processing. Derivative f prime.
Oh my god.
This video will not find it funny.
Oh, okay, then.
It's at bleach me.
Oh, yeah. Start
Me.
something up. So funny.
We should sue. Alright, so tangent inverse of 2x plus 1. How do you think the derivative of tangent inverse? Who's u prime? You see how I plugged in 2x plus 1 for the u? U prime is 2. So therefore, would you have been able to make it match? Uh-oh. Would you have been able to make it match? What happened? What did I do in between here and here? I foiled, right? Which would have been 4, foiled, remember? Multiply the first, 2x, 2x. 2x times 1 double to be 4x. 1 times 1 is 1. If you need to write it out, 2x plus 1, 2x plus 1, first, outer, inner, last, put them all together. 4x squared stays, 4x stays, 1 plus 1 is 2. I can factor out a 2! Why is this a little tricky? If you get here, you might be like, well, sweet, whatever one has a positive 2 on top. Yay, pick it! But the answer in this one, the 2 cancels, reduces. Just be careful. Did we get it? Okay. Oh! Uh-oh. Yeah, pretty much. I think we're done. Are we totally done? Almost. We just have 2 more. And we still have 20 minutes. Oh, we're good. We're golden. Why did I give you a cosecant inverse one? Because I gave you a messy one. We've done lots of sine inverses. We've done lots of tangent inverses. Oh no, we haven't done a cosine inverse. You're going to be helpless. Just kidding. Cosine inverse is who? Sine inverse is formula, but with a negative. Oh no, we didn't do a cotangent inverse one. You guys are helpless. Wait, cotangent inverse is the same thing as tangent inverse, but with a negative. We haven't done a secant inverse. That's okay, we're doing a cosecant inverse. Secant inverse just won't have a negative. So question, what is the formula? Do you have forever 17 close? What's the formula for cosecant inverse? What do you notice about the order of secant and cosecant inverses as compared to sine and cosine inverses? Of what's under the square root? Aren't they flipped? Sine inverse and cosine inverse has 1 minus u squared. Secant inverse and cosecant inverse has u squared minus 1. Struggle, how are we going to remember that one? I honestly don't know. I haven't had kids give me a way to remember these formulas. I just think Pythagorean, but that's not going to help you. Does anybody have an idea? Sine inverse, cosine inverse, 1 comes first. Cosecant inverse, secant inverse, u comes first. I don't know, think about it. It's a common mistake, switching you around. Bridget? I do, thank you. I almost forgot it because I got too focused on the order switching. So, who's my u prime? Good job, kid. I got too distracted. So now what? I don't know. Can we make it, remember the 5 belongs up top, 5 times -1, -5, all over absolute value of 5x times the square root of 25x squared minus 1. Question, would you have been, struggle, able to make it match if the answer was -1 over would you have known that was legal? What did I do? I canceled out the 5. Oh, but the 5 is in the absolute value. That's illegal to pull him. Wait. What's 5's sign? Inside or outside? Positive. Am I at all detracting from the absolute value, keeping this quantity positive if I pull out a positive number? Who's the one that needs to stay inside? X. Because if I plug in positives to X alone, it'd be positive, negatives to X alone, negatives, I need that to stay just like he is. But the 5, I don't care about, whatever. 5's a 5's a 5, pull it out and cancel it. We're good to go.
It was like absolute value of x times like quantity x squared plus x. You couldn't pull up x in one.
But what if it was absolute value of X squared? Does absolute value have any meaning? Wait. What if it was absolute value of X squared? Do I need the absolute value anymore?
No,
Why not?
because anything squared is always positive.
Anything squared is always positive, so this is kind of like a double positive. I don't need both of them, the X squared suffices. So sometimes you can take away the absolute value if the quantity inside is always positive anyway. The X by himself, he can be positive or negative. He's stuck being positive. These don't mean the same thing. These do, those don't. Anyway, just something to keep in mind as you're simplifying and trying to think about making it match. Last example. Oh no, what does it mean when it says find the slope at the indicated point? This is like nothing we've done before.
Extra work.
No, it's not that bad. It doesn't say tangent line equation, it says just the slope, and slope means what? Derive it, and? Plug in point. If it needs x's and y's, we plug in x's and y's. If it only needs x's, we only plug in x's. But if it wants a slope, the slope, I need to plug in the point at the end. Alright. Derivative, dy dx equals, why not? No, it's not a y by itself. Now I could take ln of both sides. Let's just go for it. So d dx, I'm just doing implicit. I'm just going for it. I figured they gave it to me for a reason. What's the big rule I need on the left-hand side? Read it. X times, I need a product rule, right? X times arctangent of X. A few of you are still getting stuck on the difference between a product and a chain rule. If it's an of, ln of, e to the power of, square root of, all of those are chain rules. Sine of, but as soon as there's a times, I need a product rule. You have to know the difference. So, I have arctangent, second D first. Arctangent is the exact same thing as who? As tangent inverse. Second D first, arctangent of x times 1 plus first D second, x times, who's the derivative of arctangent or tangent inverse? 1 over,
1 plus u
oh,
squared.
sorry, I thought we did that. 1 plus u squared times u prime. Oh wait, who is u for arctangent? It's just x. So 1 plus x squared times, what's x prime?
1.
Equals, does that make sense? 1 over 1 plus u squared, u is x times u prime, which is just x prime, which is just 1. And how do I take the derivative of e to the y?
Do the y times y.
E to the y times dy dx.
What if in the beginning you just threw in some ln's
You could have.
and then
The only reason I kept it this way is because without some sort of direction leading you that way of like using logarithmic differentiation, my guess, my best guess is that the multiple choice answers are going to have an e to the in it, which means they didn't do ln. But you could check out the multiple choice answers real quick and see if there are ln's instead, and if so, then go for it. But I'm just trying to have us end where they expect us to end, so that it'll match easier. Long story short, we need to get dy dx by itself. I'm going to rewrite this side just to make it a little bit nicer. X belongs up top with x times 1 is x. 1 plus x squared belongs down bottom. Equals. I'm going to say dy dx because what am I going to do to the e to the y? Divide it. Now, to make things a little easier, can I do 1 over e to the y and it means divide by? Isn't that easier a little bit, right? Last step. Oh, we're not done? Plug it in, plug it in. So I can plug in the point, I can do a little such that for this entire shabam. So this whole thing such that I have the point 1 and ln of pi over 4. Just showing you I'm about to plug in. So, 1 over e to the ln of pi over 4. Why? Yeah, exactly. Why? Because it's a y, so we plugged in the y. Arctan. It's like got groans on that one. Arctan of 1. Right? Because that's the x. Make sure to keep everything straight. Just a few of you are mixing up your x's and your y's. 1 plus 1 squared is, well, that's just 1, right? Equals dy dx. We have to simplify? This is awful. Wait. E to the ln, aren't they inverses of each other? Ln of e, they cancel. E to the ln, they cancel. What's left? Pi over 4. Wait, 1 over pi over 4. Can I just make that the reciprocal 4 over pi? Yes. Move this down a little bit, sorry. Keep going back. 1 over, remember, e to the ln, they undo each other. I just have pi to the 4. 1 over pi over 4 is just 4 over pi. Arctangent of 1. Ah, stink. Wait, this is one we should know. At what angle is sine and cosine the same? Hence, when you divide the two, they end up just reducing to 1. Pi over 4s, and if it's a positive, I just want positive pi over 4. Oh my goodness. Plus 1 over 1 plus 1? 1/2. Could that be the answer? Yes. I'll box it. I'll box it. But I see something that makes me think that just maybe they might go one step more. They might do a common denominator-ish sort of thing, and or they might distribute. So you just have to look and see the multiple choice answers, right? If you distribute, isn't that just gonna, the 4's cancel, the pi's cancel, right? That'd just be 1 plus, if you distribute, everything cancels, reduces to 1. If you distribute again, the 2 and the 4 cancel to be what, 2 over pi? So it could be that one. Or, if they had gotten common denominators, I suppose, times pi over pi, that'd be pi plus 2 all over pi. Why do I do things like this and show you all these different possible versions of an answer? I can't guarantee what they're gonna do, and I need you to be able to make it match, and not just be confident in your answer, but also be willing to simplify it different ways if need be. Does that make sense? Oh, sorry. Kiddos, if you haven't written down the homework assignment yet, I'm going to go ahead and pull it up because I'm done. So if you haven't written in your spiral, you can go ahead and get it up. If you have any questions on 2.6a from last night, we have just a little bit of time I can help on. And if you need to borrow a book, I have very few, but if you want to come borrow one, you may. My advice would be to bring it. Who is it? Maya. Senora wants to see you. Yeah. Yes, you may. Alright. If you guys haven't written down 2.6b yet, there it is. If you guys need a book, I have literally two you can borrow. If you have any questions from 2.6a, I'm here to help.
I like that.
They ring in my mouth. Sorry about the tardy too. I'll drop off the Chick-fil-A stuff.
Yeah, go ahead, Kim.
So much right now.
Gotcha.
Okay, you do the first one.